So in the context of continuous delivery, I want to share some experience that we have acquired over the last few years, helping organizations to take a monolithic system and decompose that into smaller bits, crucially without destroying the team. So today there's some things we'll look at. We'll look a tiny little bit about cognitive load for teams. We'll explore what monolith is, what it really means. A little bit on code forensics. Think about boundaries of software components from the perspective of the team. And there's a recipe at the end which allows you to split the monolith nice and easily. But actually, just for now, we're going to forget the M word, which is microservices. We're going to forget CQRS, event sourcing, fancy stuff like queues, blah, blah. I know this is really heretical not to get excited about microservices, but we're just going to just pause, just bear with me for now. You'll see I'm a true believer later on. I co-founded with Rob Thatcher, who's at the front here, a consultancy called Skelton Thatcher Consulting, and we do stuff, including continuous delivery, for lots of different organizations around the world. We've got clients in China, Europe, UK, Ireland. And this is kind of what we do within organizations. We get down and dirty with the innards of what's going on and try and fix it. I mean, not literally that. That's not my backside, but that's the metaphor. That's the kind of thing we like to do. Anyway, so how can we break apart a monolith without destroying the team? Why would we even care? Well, we care for this reason. Because we want safer, more rapid changes to software systems. Why do we care about that? It gives us increased business agility. And that's something worth paying for. If you want an easy way to think about this talk, it's this slide, which is a team-first approach to considering the boundaries of software subsystems. But starting with a team, not starting with some big UML diagram or some other concept of what the software is. So we start with the team. And we often say that. What I really mean is actually properly start with the team, put that right in your face and really think what that means. So what are the capabilities of the team? What can the team actually do? What's the team's appetite and aptitude for working with software? Do they even have the right skills? Do they care to acquire the right skills? What is their current level of understanding? In other words, what are they actually able to be responsible for? There's something we need to introduce called Conway's Law at this point, which I'm not going to state it in full, but I'll use diagrams to explain it. This is an extremely simplified explanation of Conway's Law. If we have, say, 4 development teams and a single overworked DBA, taking all the changes and so on, then the architecture that we'll get out will be on the right-hand side. You'll get kind of 2-tier and then a central database. That's a kind of very, very simplified view of Conway's Law. In other words, the architecture of the software tends to reflect the architecture, if you like, or the team relationships within the organization. Now, there's something called reverse Conway, which is not in the Kama Sutra, but it was actually a term introduced by, I need to get his name right, Tobbe Gillebring, I think from Norway or Sweden. And that means if you want a microservices-y-ish architecture, nice thin vertical slices of business domain aligned functionality, then logically speaking, we should make sure that our teams, so in other words, here we've got in blue we've got some sort of client, in green we've got an API and some sort of data store at the back end, and logically speaking what we need to do is make sure our teams have someone working on application development, someone working on API development, and someone with a data capability. So that's the kind of, again, super simplified, but that's the concept. Alan Kelly calls this the homomorphic force, meaning the same shape. So our software architecture naturally takes the same shape as our software organization. Again, that's greatly simplified, but that's the idea. That makes sense so far? Okay. I think it's important to think about what a team can take on in terms of its collective brain and kind of abilities, technical abilities. So I'm in the process of kind of working through and expanding this section of the talk. But the good thing is that we've got science, got some science to back up some of this stuff. I'm not going to go into a huge amount of detail about the individual papers, but we've got scientific papers going back to at least 1993. There's lots of work done by people in the US Navy. 2 of these papers are from the US military, 2 are not. The point is that people have studied the effect of stress and cognitive load on teams and how teams perform under stress and under increased cognitive load. And these are peer-reviewed and what have you. The point here is that we're starting to characterize what happens to teams when they've taken on too much, in effect. And what pops out is that stress impacts team performance by narrowing or weakening the team-level perspective required for effective team behavior. So if we go back and just for a second think about what Pierre was saying about teams collaborating on API contracts. If the team has taken on too much and has too much to think about as a team, then they stop performing like a team. Perhaps they'll stop collaborating on API contracts with a consumable provider. That can't be a good thing. So that's a very, very, very thin slice through what's actually quite an important and nuanced topic, but I just wanted to point out that kind of set the scene, if you like, for thinking if we're adopting these kind of approaches with CDCs and PACT and so on, and similar approaches where we're introducing a large number of smaller components and expecting to be able to mutate and change these on a regular basis, then we must take into account the ability of the team to be comfortable and confident that they can make the changes that they need to make on a regular basis. If they're under stress, if they're taken on too much, then the science tells us that actually we'll get bad behaviors out, we'll get behaviors out which work against that kind of delivery model. Okay, what do we mean by monolith? There's 2 great quotations here coming up. So Stefan Tilkoff from InnoQ says, don't start with a monolith when your goal is microservices architecture. Okay, that's fine. He's super experienced. I absolutely love his talks. But Tamer Saleh from Pivotal, in fact, says start monolithic and extract. Now these are kind of two ends of a spectrum at least. So what's going on here? Because these are 2 people with lots of experience. I think what's possibly missing here is that there's an extra dimension that we're not seeing, which is the team capability. So I think those first 2 quotations are coming to this from the point of view of kind of software architecture and the technical side. I think at least one more dimension is what the team needs. So that's what I'm trying to do with this talk, is to kind of add an extra dimension to thinking about breaking up monoliths. There's lots of different kind of monoliths, and I'll go through these in a second. This is a literal monolith. It's a single piece of rock. It's actually a carving from the stonemasons at York Minster in the north of England. Anyway, when I was there on holiday once. It's not all about my holiday snaps, by the way. I've done that before, but not today. Anyway, so it's a single block of code. It's deployed as a unit. You can't take it apart without actually breaking it. But there's other kind of monoliths where, a bit like this, they're joined at the database. So the database in this picture is kind of that big slab at the top. And it's difficult to change separately, but you can do. You can make changes to the other services and things, but they're kind of joined somehow. It makes it quite awkward and probably quite risky. But we can have a situation where we've got kind of a monolithic release, where we've got lots of small components inside a big release. And in theory, you could deploy one of those small components separately, but we've kind of somehow bundled it all up into one big mesh, big box like this. And so we're sort of hampering ourselves. I mean, there are some advantages, but we're sort of hampering ourselves by deploying things like that. And then I ran out of pictures of rocks to work with the metaphor, so I got pictures of kittens instead. Now this, bizarrely, there's a service you can get on the internet where you send a picture of your pet and they'll make you a stuffed version as a plush toy. So I think it's the one on the left, which is the live version, and the one on the right, which is the plush, but I'm not sure. It's so bizarre. Anyway, So the point here is that the idea of just cloning the same kind of patterns and technologies across every single team is quite common. There's quite a lot of organizations that assume that one size fits all is the way to go. They think that it's more efficient. They think that it's simpler somehow and better. But in our experience, that's very rarely the case. We might expect some sort of eventual consistency to emerge in terms of good practice. So you might expect to see, well, no more than a couple of different databases in use, or no more than a couple of different styles of doing APIs, rather than one style per team. Because if you have a completely separate set of technologies for each team, the implication is that they're not talking to each other and sharing good practice. But with the monolithic thinking, we're talking about that being mandated, kind of the similarity being mandated, which doesn't feel like a good thing. There are some dangers of splitting a monolith, right? So monoliths do provide some useful things. They provide kind of forced consistency. We're forcing things to be consistent because we're building them or deploying them or aggregating data together into the same place. We might get data duplication if we're splitting a monolith because we've no longer got a single central database. There's definitely additional operational complexity because we now very much have a distributed system, particularly if we've got network calls across HTTP. By definition, that's distributed. And potentially, you've got a degraded user experience across the product. Who's heard of the Spotify model for organizing teams? Who has Spotify? Who uses it? Who's noticed that it's that you can see that the teams are not? Yeah, you can see difference in different parts of the UI. So, is that a good thing? I don't know. It's definitely a potential negative outcome of splitting a monolith. Crucially, we need to choose. So this is actually how you split a literal monolith. I did some investigation, right, in terms of the metaphors and things. We need to understand what kind of monolith we've got first before we decide the approaches for splitting it. Otherwise, we'll use the wrong approach. So back to the kind of actual real-world metaphor. These characters are splitting slate in a mining Cornwall, and what they're doing is they're laid. So slate is made up of very flat, thin, flat layers. That's why we use it for roofing. And what they're doing is they're splitting it along the natural kind of plane of the rock, and that makes it much easier to split. A kind of fracture plane, if you like. So they're working with the material in a way which is kind of sympathetic to the material. This section here should be much expanded. I ran out of time to expand it further, but I'll explain what is a bit bullet pointy, so apologies for that. I wanted to spend a tiny bit of time exploring some of the kind of fracture planes, if you like, that we find in code. So in no particular order, we can look at the kind of business domain boundaries. So you might have one thing around kind of, if you're doing a shopping cart, basket is one sort of bounded context. Maybe my profile is another context which feels quite separate, and so on. So things that map to quite nicely segmented parts of the business domain. Sometimes we have an area of the system that is subject to regulatory compliance. So it could be, for example, PCI DSS. And that needs, usually, if you're implementing aspects of it, needs an entirely separated system for the cardholder data. So that forces a part of the system to be separate. Different systems might naturally change at different frequencies. So one part of the system might naturally change very slowly, one part might naturally change very quickly. That's another kind of fracture plane that we can look at. The business appetite for risk for different parts of the system can be very different. So we worked with one company in north of England who they had essentially they had several, had at least 4 or 5, but 2 main kind of blocks of system. One was considered much higher risk than the other one. One was essentially content. The lower risk one was sort of content-ish, and the other was kind of transactional, quite a common split. But they'd somehow bundled together their release process so that they were deploying both of these at the same time. So everything became high risk. So there's another fracture plane there. We can split stuff out that's lower risk, and we can deliver that more frequently. And there's other things as well. User persona is an interesting one. So, for example, if you've got part of the system which is only used by an administrator, that's a candidate. Could be a candidate for splitting something out as a separately deployable thing. Team location is a big one. So if you've got, and this is Conway's law coming into play now. So if you've got teams split across multiple different parts of the world, if the team feels like they're not in the same, if you ask the members of the team and they say, actually, no, it feels like we're actually 2 or 3 different teams, that's a good signal to split things out into 2 or 3 different pieces and actually potentially have them work on different bits of the system. All right, I want to talk a little bit about code forensics. There's a really, really excellent book. If you like any of this stuff at all, get this book. I don't have any shares in Prog, or I don't know Adam personally. So Your Code is a Crime Scene by Adam Thornhill. Absolutely awesome. Adam Thornhill has a background so he writes compilers and compiler tools, and he worked as an actual forensic scientist for several years. So he actually has a proper background in both. There's a really good video you'll be able to see in the slides later on. He gave a TEDx talk on these techniques, and one of the tools that he's written is called Code Maat. Now, Maat or Maat is an Egyptian goddess of truth and justice and clarity. And so what his tool does is take the hieroglyphs of our code in our Git repositories and translates it into things that are more meaningful, including things like this. So this is a combination of a tool called Code City, which analyzes code bases and draws kind of skyscrapers based on the kind of number of lines of code and various other metrics that you find in code bases. And what he's done is something really, really cool, which is to then color code it with additional data, things like code churn and likelihood of bugs and things like this. So he's extracting very, very useful data out of code bases. And we can use, there's more to say on this, but we're not going to have time today. But the point here is that we can actually inspect the history of code bases to give us additional signals for where to split. So for example, if this were a single repository, you might look at this and say, that's quite interesting. There's a piece that has very high churn in the top left corner with the kind of green and red bits. That could be an area which is a candidate for a separate subsystem. Depends on the detail. But we can actually use our version control systems to tell us some useful stuff about maybe where some of these boundaries are. There's one really important thing that's in the code, Adam's book, that rings very true for me, which is beware of badly named anything, but particularly beware of badly named subsystems. So he says literally, information poor abstract names are magnets for extra responsibilities. And what that means is that if you don't have good names for different parts of the system, they will tend to accrete extra code and extra responsibility into them, and that's not the right place for that stuff to live. Okay, so I'll talk a little bit now about starting to bring some of this stuff together. We've done quite a bit of work with several organizations now around the boundaries of responsibility for different teams, different patterns for organizing team responsibility boundaries. We curate this website, devopstopologies.com, which you may have seen before. There's a kind of collection of, is it 15 or 16 anti-patterns and patterns for kind of bad ways to set up teams doing modern software development and better ways. What we've sort of realized is this. There's basically only 4 team types that you need to concern yourselves with. And that's a product or feature team, so something that's aligned to a domain boundary, business domain boundary. A platform or substrate team that provides something for other people to build on. A component team where you've got a piece of the system that's really gnarly or really complicated or needs a PhD in maths to understand, or chemistry or something, then that's a reasonable candidate for actually splitting off into a component and having just one team work on that, because it would be too complicated or even unwise to allow the feature teams to actually to dive in there. And a kind of supporting or productivity team, helping other teams go more quickly. And yeah, there's you can debate about this. We can have a chat later if you want. But these four types here seem to cover the vast majority of cases. And let's put these in context. If we were to kind of draw out the responsibilities, there's sort of a flow implied from left to right here. So we've got 4 feature teams. The top one of which is actually collaborating with a platform team on maybe some new microservices-y stuff or some new monitoring stuff, or God knows what, Kubernetes maybe. There's a component team in pink at the bottom which provides services to 2 of the, or which is used, the components used by 2 of the product teams. And there's some sort of supporting team across the middle that maybe does like build engineering or something like that and helps the other feature teams to go more quickly. And there's a bit of DevOps there in green, but we'll ignore that word for this evening. So the point here is that another thing to think about is given that there are kinds of teams which work really well, and we understand what the responsibility boundaries are in a kind of industry context, we can look to map subsystems onto one of these team types. And if a subsystem doesn't map nicely onto one of these team types, then it should make us pause and think, have we got the boundaries right? Because we pretty much know that this kind of combination, this sort of pattern can be made to work really well. If we've got a component which doesn't really fit, have we got the boundaries right on that? Because it's likely to cause friction if we try and give it to a team. I want to say a tiny bit about code repositories. So the kind of first point is, in general, we should be aligning a version control repository to a subsystem or component or what have you. And we should definitely avoid version control systems that tend to make things monolithic. And I've been really trying to love TFS as a version control system. Well, not trying to love it. I've been trying to kind of put my skepticism aside for the last about 3 years. And it's just awful. Every single client we go into that's got TFS, they've got a massive monolith and all the code's a mess and it's horrendous every single time. So, I mean, you could do the same with Subversion, you could do the same with Git, right? But it seems to be particularly bad with TFS for some reason. So if we've got something that we want to deploy and run, it has its own version control repository. It's kind of as simple as that. And I came up with a bit of a rule this afternoon. So Google use a mono repo, and there's people talking about it, and people, oh, should I use a single Git repository? Should I use... Basically, if you've published a scientific paper in a peer-reviewed journal, then you can use a monorepo, that's fine. But otherwise, just stick to one repository per deployable thing. Much easier. So what we're doing here is we're trying to find the natural or available fracture planes for splitting the monolith. We're working with the material we've got, the business domain, the technology, the regulatory constraints. We're not trying to design a fancy architecture up front. All right, so here's the recipe for splitting a monolith. It goes like this. First of all, we're going to instrument it using logging and metrics. Then we're going to try and understand the data flows and fault responses. Then we align teams to these segments. And finally, we start to split these segments off. I'll go through this. I realized that there's something missing from these slides, but I'll come to that in a second. So first of all, we're going to instrument the monolith. What do I mean by that? So here's a monolith, one big block, right? That's a monolith. Well, it's rarely actually like that, right? Because if we've had any decent software developers in the building at all, inside that, there's going to be some packages and some namespaces and stuff like this, right? There are going to be there's going to be some differentiation inside. So when we start instrumenting it, we use at least 2 techniques, one of which is a correlation ID. So that's just some sort of unique-ish identifier that we attach onto the inbound request. And we pass that through all the different layers until it pops back out again. And we also use, what I call event IDs, some people call different things, but basically it's whenever we reach a certain point in the code that's interesting, we give it a specific identifier type. So database connection refused, for example, or a postcode lookup service failed. And every time we hit that event, we log that in through a logging mechanism. So it allows us to do things like this with our in this case, Kibana book, any kind of log search thing. I can search for database star, it'll find me all the times that I hit an event that was related to the database. So we're using logging as a kind of mechanism to make this system more testable, to understand what's happening when we actually run our system. Now at the moment, this system's still monolithic, but we still, if we plug in this instrumentation at the beginning, it helps us to understand certain things, as we'll see in a sec. So we need to understand the data flows and fault responses. Let's say we plug this stuff in. Actually, what it turns out that there's something unexpected, because we actually we didn't expect that the block on the left in orange is collaborating with this block in blue. But by logging this stuff out using event IDs and correlation IDs, we actually discover a pathway through the system that we didn't realize existed. And we also, in this case, discover, can you see there's kind of 4 event ID logs in a row? Something is retrying some connection very rapidly, perhaps it's failing. We didn't really understand that failure mode before. So now we've got a better understanding of how the software actually works. So what we can do is we can adjust the internal boundaries of that system so that it doesn't call out into a separate subsystem. This is still a monolith, but we've cleaned it up a little bit first. So all of that call is now inside that kind of stack, which is yellow, orange, black, which is where we expect it to be. And we're in a good position. We're in a better position than we were before. There's some additional techniques, for example, like using kind of runbooks to collaborate up front on how we expect the system to behave. So this is a technique that we've specifically used with some clients. We'll print out a big old sheet about sort of A1 size, about the size of one of these tables, and get people to sit around it, and they actually talk through how they expect the system to behave, add in additional information to the correlation IDs or to the event IDs, explore the delta between expectations of how the system works and how it actually works. Anyway, so having done that, we can start to align teams to these available segments. So generally speaking, we're looking to map as many of these to business domain segments as possible. So what we've got here, does that come through? Yeah, it comes through on the slides. So we've sort of got 3 kind of vertical slices, business domain segments. So we've got one sort of component or platformy thing at the bottom, which feels a bit more gnarly, a bit more awkward to for the business domain teams to do. So that's fine. So what we've ended up with in this particular case is 4 teams. And then we split off the segments one by one. So we split off this first segment here. That's now a separately deployable thing. And then eventually we split off into kind of 3 separately deployable things. Each has its own build, each have its own infrastructure in terms of machines or sets of containers, whatever. Its own deployment, its own versioning, its own lifecycle. Now you still might build the one on the left altogether, yellow, orange, black slice altogether for now, and then at some point later you might split it further. But what we've done here is we've made sure that the teams involved are able, willing, skilled up enough to deal with that slice of what they've been given. So the team needs and responsibilities come first. Just to re-emphasize that, there's the team again. So how to break apart a monolith without destroying your team is to do all these things, instrument the monolith, really understand how it actually works first, understand the data flows and fault responses and other operational things, line up the teams to the kind of available segments and split these off one by one. But we need to make sure that we don't forget the team. So the team's always in the background now. The additional thing I would add on to this now actually is actually the stuff about CDCs or packed as a specific call out, because I think that is very empowering. And that's it really. I wrote a book earlier this year. Anyone who works on the .NET framework, there's a free book you can download from O'Reilly, Continuous Delivery Windows and .NET, so I'll cover some things around this. And with Rob, we're busy writing a book on software operability, which again covers some of these things off too. At the end of this slide deck, which will be online later, there's loads of links to things like different books, training even from Sam Newman. He's got a training course, so the guy who wrote Building Microservices, he's got a training course. I think the first one was in 2 weeks' time online. Anyway, I don't know whether it's any good. It's there. If you're interested, I would have a look. There's some talks and slides and other stuff. There's all the science as well. So hopefully that's interesting if you want to go and follow any of that up.